All right. Exponential growth and decay. There's a base, just like there is for a lot of the things that we've done with base. And that base kind of works here, and understanding A and B is going to be critical to understanding kind of how this whole growth and decay thing works. So if something's growth, we're going to blend the growth and decay together, learn about them at the same time. The key here is our B value. This B value that we work with lets us visually see, before we see a graph even, if it's going to be growth or if it's going to end up being decay. If it ends up being a B value that's greater than 1, okay, B is our base, it's going to end up being growth. It's going to go up to the right. So I'll go ahead and I'll get that in here. Because sometimes, the calculator is going to be fun for me today to play with. I might have to have it go away here for a minute. Calculator, be gone. Okay. It can come back in a minute. So, that's going to go up to the right. If it's a fractional, and notice these are all positive bases, that's going to be down to the right. Now, again, if you see the picture, it's kind of easy to tell if it's going down or going up. But sometimes just having a little bit of an idea of this will help us. But that B value that I keep talking about has an official name. And depending on if it's growth or decay, it's your growth or decay rate. Okay? How fast is it getting bigger? How fast is it getting smaller? And that's something that we're going to have to take a peek at. Businesses take a peek at that all the time, trying to figure out, how much money are we going to make going along, or how much are we going to, when are we going to run out of something? It's something, kind of something handy. So, when I'm looking at this, I can kind of tell, without even looking at the graph, is this growth or decay? Okay, it's growth. It's going up to the right. But, a couple of things to keep in mind. One is, if I keep recognizing this thing called my B value, okay, my growth or decay rate, I notice my B value is 3. Well, anything greater than 1 is going to be growth. So that's kind of the way that I want to take a peek at that. That would also be my growth rate. Okay, so for everyone it keeps going along on my graph, it's going up 3. What about number 2? What's my B and is it growth or decay? Okay, that one's going to be decay. And what's my decay rate? 1/2. It's always that number that you're taking to the x power. It's going to be your B. It's going to be your rate. So don't get fooled by the numbers that kind of sit there in front of it. So sometimes it might be that easy. Other times we're going to have a little more work. Let's pump this up a little bit. Graph the function. Classify if it's going to be growth or decay. Now, before I even concern myself with the actual graph of this, what's my growth or decay rate for this one? 2. So since my B is 2, before I even draw it, is this graph going to be growth or decay? Growth. So I know that this graph should be going up to the right if I've done it correctly. Now, with something like this, the x values that are here, I could just go ahead and plug them each in manually, and then go ahead and plot them. Or, I know some of you prefer this type of method, I could go to the calculator if I wanted to at this point, and say, okay, I want to know what 2 to the x is going to be. And I could go ahead and I could graph that, and I see, okay, it's growth, it's going up to the right. But again, I want to be accurate. I don't want to just do a complete sketch. So if I don't want to manually do all the math there, I can always do second graph to get my table up, and it'll give me the values that I want. And I don't mind if you go into a decimal mode here, even though I think you'd see a pattern better with the fractions. Because, for instance, that 0.125 that you see, just a fancy way of saying 1/8. Okay. 0.25, and we know that's a 4. And the main thing here is seeing, oh yeah, these negative exponents don't make negative answers, they make fractions. Anything to the 0 power is 1. And then you'll start to see what happens with your reciprocal here. 2 over 1, if I flip it, is 2. Okay, 2 and negative 2, again. Reciprocal. Or reciprocal of 1/8 is 8. Okay? I can get that again from the table, or I can just do some mental math on that. That's going to allow me, once I do that, the opportunity to just plot my points. Now here's one thing that you're going to find out that's kind of critical. Let me get this turned back on for a second. When I sketch, notice if I keep going into the more negatives, notice the numbers are getting smaller, but they're not crossing 0. Okay? That E number means I'm really, really close to 0, but I'm not actually going over the axis. So when you draw your line, make sure that your graph isn't crossing the x-axis. Okay? We don't want to get sloppy with that. But now I can get all this information that I need once I have the graph. So if I boost that up a little bit, what's my growth rate? 2. It's just that B value. Definitely growth this time. Okay. Where's my y-intercept at? Okay. It's at 1, but anytime we're talking about a specific point, it needs to be a coordinate. So it'll be 0 something. 0, 1, if it was negative 2, it'll be 0, negative 2, whatever that happens to be. And then remember, our domain and range when we're doing these, domain is my x values from left to right, and range is my y values from the bottom of my graph to the top. So when I'm looking at domain, looking at my graph from left to right, where does it start and where does it end? Okay? It starts at negative infinity because this arrow is just going to keep going and going and going to the left. And right, positive infinity, because even though it keeps going up and up, it's also expanding out and out and out. Typically, more times than not, your domain with these types of functions are going to be negative infinity to infinity. Very rare case with domain that it won't be. Now range, we got to do a little more thinking. What's the absolute lowest point of my graph going to be? You're like, it's never going to hit 0, so I have to use a parenthesis, but it's going to come up really, really close. So my range would say, everything not including 0, but just above it. And where is it going to head as far as top goes? To infinity, because it goes up forever. So where that bottom point is, which we'll find out later is called an asymptote, is, because I go, what here we go with that, is an asymptote, and it just is kind of like a border, a wall that your graph can't go through. And then our other favorite, end behavior. Now again, we're not just saying up, down, left, right. This is that whole thing again. If f of x approaches something as x approaches. And again, with your x's, one of them is always going to be positive. And one of them is always going to be negative. Now, I can still think of it as x goes to positive infinity, as x goes to the right, what's happening to y? Okay, right. As this goes to the right, y is heading off to infinity, positive. So I can put that in. So basically what I'm saying is, y goes up, as x goes to the right. I'm making a verbal description of what it is. So as x goes to the left to negative infinity, what's my y starting to approach? 0. You're like, ooh, that's the first time we've done that. It's always been some sort of infinity. Well, in this case, it's not. There's actually a stopping point. So my y is going to approach 0 as x goes to the left. And that's how these work. So it kind of blends in some old stuff with a little bit of new. And again, if we get into one of these, you're like, okay, I see what you're doing on part, Well, why is this happening again? Stop me, because I do. You probably wouldn't be the only one with the question. And me being the goofball I am, think, oh, this is bad, let's keep rolling. So we kind of this over. Okay, so 4, we'll kind of start the same way. Okay, is this one going to be growth or decay? Why? Okay. Yeah, my b value is fractional. So we're looking at decay this time. Know my growth rate, so I'll get that in. And again, like we did before, I can either pop these in manually, or I always have the backup plan. So if I start here, I can either put the 1/2 in parentheses, or what's 1/2 of the decimal? 0.5. So I could just do 0.5 to the x if I wanted to. So I look at that, yep, looks like decay is going down to the right. And you'll find something interesting when you look at the table this time, though. Starting at -3. Yeah. If you start to fill in the table, oops, already hurt. How does this table compare with the last one we did? Yeah, it's just a reciprocal. It's just the inverse, okay? So when I go to graph this one, I'm basically looking at a mirror image reflected over the y-axis. Just like before, make sure your graph goes down close to 0 but doesn't go through. And what we'll find is there's going to be a lot of similarities with these two. So let's see if we can get some info here. Y-intercept? Okay. Still at 1. And you'll start finding out, unless you see shifts, and we'll get into those a little later, your y-intercept is always going to end up being here. Domain? Working left to right here. Infinity to infinity. Because even though it looks like this just starts to go up and isn't really going out a whole lot, it still is slowly working its way out to the left. What about my range? I like the thought process. The dilemma here is, because we're so used to looking at it going, well, I'm starting, up here. And I was ready for somebody to even say infinity to 0. But it's bottom to top. So where's my lowest value in this graph? It's still at 0. And it still goes up. Just because it's going from right to left, kind of when you're looking at it, as far as your bottom to top, still doesn't change the fact that that's my range. It's still always where's the least value, then where's the greatest. So even though it looks a little different, my range can still be the same. But is my end behavior going to be the same? That's the question here. Let's go off the bottom of the screen. So I know with my x's I need 1 of each. So I always get those drawn in first. That way I make sure I don't lose them. So let's see. As x heads to the right, what does y approach? 0. Okay, so as my graph keeps going to the right, y is approaching 0. What happens as my graph is heading to the left? What happens to y? It goes up towards positive infinity. So basically on this one, my end behavior is just flipped. But those are the types of things we're going to be looking for in these. These are the types of things that businesses look for. And we're going to do a lot of application work in this section. You'll kind of get to see what the point of this is, why things work the way they do. In this next part, we're going to take a peek at what certain things start to do to our graphs. So on these, sketches are going to be fine, because I just want you to get an idea of how these different things affect your graphs. So let me clear this out. First one we're going to keep real basic. We're just going to look at this 2 to the x here. 2 to the x, he goes, nothing. He goes, okay, that kind of looks like what everything else has looked like. So basically, it kind of looks like, okay, coming along here. Now, where does it look like my intercept's at? It still looks like it's at 1, okay? Then maybe I can get one more point here. 2 to the first would be 2. So it looks pretty basic. You're like, okay. But now, let's keep that one. Let's go down to the second one. And we've got 2 times 2 to the x. Now let's see what happens with the second one. Okay, it looks like it's still approaching 0 to the left. Where's the intercept now? The intercept now, if I take a peek, okay, for my first graph is at 1. Now my intercept's moved to 2. That's interesting. I wonder if that has anything to do with this 2 that's out front. Yeah. Well, let's find out. Let's get one more going on the same graph, and then we'll start erasing some things. 5 times 2 to the x. Let's see. Oops. 2 to the x. There we go. Let's see. Let's bring the table up. Was it 1? And the second one I moved to 2. Third one I moved to 5. Amazing. So what you start to see is a couple of things here. I start to notice, okay, it's still approaching 0, but as that number in front gets bigger, my intercept's moving, and it's starting to get steeper. Just something to keep in mind. But, I'm going to wipe these last 2 out. Maybe. Because now I take a peek, and I look at that fourth one. So I've got -1 times 2 to the x. What do you think may happen if you haven't peeked already? Yeah, I think we might be looking at heading downward here. There it goes. Basically, you see a mirror image again, except now it's about the x-axis. Because again, when you're comparing 2 to the x, and this is like looking at more like a negative, it's just going to take that entire thing and flip it downward. The intercept won't move, but everything else would basically be a mirror image. And just like it was when we were doing the other ones, if I do -3 times that, it's going to take the same effect that it did going the other way. The only thing that'll change is that now that intercept goes down to -3. It gets a little bit steeper. So what this little kind of mini activity here does for us is it lets us see A couple of things. So let's just see the y-intercept move, because that changed on each of them. But then what happened? Okay, the effect of A, this number in front on the graph. Well, what did it do? Right. It made it much steeper, and it also changed my y-intercept, because typically that y-intercept is going to be at 0, 1. But if I have that A value out in front, it's going to change my y-intercept to that particular value. So when A was positive, what direction did all my graphs go? Okay. So they all opened up if my A value is positive. But when we changed it to negative, they all opened down. So that number in front can have some different effects. Positive, negative, flips it maybe. The bigger the number, starts to make it kind of steeper. So again, I can get some ideas of what this is all going to be like before I even get to actually working with the graphs. So when I get to here, again, I want to let the calculator help me. We'll start clearing some of these out. Then again, I typically keep going back to the decimals on these just because then I don't worry about my parentheses as much. If you want to keep with the fraction, just make sure your parentheses are present. So 1/2 times 3 to the x. Make sure it's not 3x, but it's 3 to the x. So we start to take a look. A couple of things before we even start with this one. Is this growth or decay? Should I ask that before? Okay, it's going to be growth. What's my rate of growth? What's my b value? 3. Okay. Growth rate of 3. What's my y-intercept going to be if you have to choose one? Okay, 0.5 or 1/2. Again, that a value determines or helps me to see that. Because if I went straight to my table, there it is, okay, 0.5. And the rest of them, again, if you want to go decimally on me, I don't mind if you go decimally. I don't even mind if you do a little bit of rounding here. Because again, what this allows us to do is see just how much change occurs and how quickly it occurs. So all of these numbers that are right next to 0, of course, at -3 and -2 and -1, basically we're just saying, okay, we're going to get as close to the x-axis as we can. And then the rest of them, this one goes right off the chart here. So we're not looking for perfection, just a pretty accurate depiction of what's going on. That's what we're going to be giving a shot to here. So we already figured out growth. We already figured out the y-intercept. We already figured out that it's growth and has a growth rate of 3. So let's see here. What is my very consistent domain going to be? Left to right. Negative infinity to infinity. Okay? Because this, if I were to look at my table, as the x's continue, the y's are going to keep growing. So it's going to keep moving and moving and moving to the right. Remember, range, bottom to top. Let's bring this up for just a second, just to make sure. You're like, ooh, Hardy's talking like we're not sure. Yep, there's all those e's. We're going to approach 0, but we're never quite going to go past. So, okay, we're still good there. 0, heading to infinity. I'm with you. Then again, with our end behavior, one of my x's is positive infinity, my x is negative infinity. And again, just keep reminding yourself the right, left. So as x is heading to the right, what's happening to y? Right? Y is heading up, so we're heading off to infinity. That's our fancy way of saying up. But as my x values are heading to the left, what do I approach? 0. You're like, dang, it keeps being infinity and 0 all the time. For now, yes, it does. Might that change a little? Maybe. Trying to kind of stay consistent here in this question. Because the twist is coming. Number 6. Now, if you haven't put it in the calculator yet, growth or decay? Well, yeah. Now, why would it seem like it's decay? Because it looks like my b value is 4. Doesn't that mean it's going to be growth? Ah, the exponent being negative is going to mirror image this. So even though we look at it and we're like, well, the b value is 4, it should be growth. When I actually plug this one in, I have to be a little bit careful because that negative x as an exponent is going to do something that maybe I didn't expect. Because now it's heading downward. It's going to end up being decay. So here, I want to remind myself with one like this that a negative exponent mirrors or flips the graph. In other words, whatever you thought it was going to be, it may be exactly the opposite of that. So, hey, before I ever look at a table or anything else, what's my y-intercept going to be? Okay, 0, 3, because that's what I use the a value for. What's going to be my rate of decay? Ooh, another twist. You're like, really? Why it's got to be twisted? Whoa, why did that turn off? Okay, here comes my next twist. When I look at the graph table this time, I'm just going to put the numbers in for a minute. Because then I'm going to show you something that you really have got to watch for. Especially when the negative exponents start coming. A growth or decay rate means as you go from value to value, what is happening to your numbers as you're going upward. So like if I take a quick peek back at the last one, as I'm moving to the right, as I'm going from 5 to 1.5, okay, it's going multiply by 3. 1.5 times 3 gets me to 4.5. 4.5 times 3 gets me to 13.5. That's my rate. When I look at this one, as I'm going, I go from 3 to 0.75. Ooh, I'm going down to 0.1875. Now, if you look at a decimal, that's going to be hard to look at. So let's start up here. To get from 192 to 48, am I multiplying by 4? Yeah. To get from 48 to 12, I'm dividing by 4. To get from 12 to 3, I'm dividing by 4. But I can't put divide by 4. 1/4 is going to be my rate of decay. What you're doing to get from one thing to the next is always what you're multiplying by. So if you see that negative exponent, it's even going to mirror or make a reciprocal of your rate. But that's always the easy way to look to see what your rate's going to be. If you look from one point to the next and say increase, what do I do to get from this number to this one? And it'll be consistent. Now the one thing that's nice about this, besides the fact that these numbers are so big you can't even really graph them, they get uber tiny in a hurry. Again, just make sure you don't go through 0. We're not trying to be perfect. It's getting close. Domain and range shouldn't be a big problem, at least. I wonder what domain is. Domain? Yeah, domain is what it's been every time so far. Negative infinity to infinity step. What about range? Remember, bottom to top. Least value to greatest. 0 to infinity. It's always least to greatest. Well, somebody might be pondering and not asking, well, what if I put infinity to 0? Well, infinity to 0 would be greatest to least. And whenever we're doing anything with domain or range, it's always the greatest. So I do have to do it 0 to infinity then. But then my end behavior, just like it did on one of the examples in front, is going to mirror what I already have. So as x is heading to the right, what's y approaching? 0. As x is going left, what is y approaching? Infinity. So basically, with the calculator, drawing it isn't a big deal. It's figuring out, what are some of these other parts and how are they occurring. So I can figure out a lot of this before I even graph it. Almost there. Right. I'm going to go past these next two. I'm going to come down to 9 here. Because there's one more thing that we have to kind of tweak in here a little bit. Let me get this out of the way for a second. Typically, when we start to translate fancy words for shifting. Okay, here come horizontal and vertical shifts. Now, this is stuff that's been done with parabolas. It's been done with square root functions. And now we're going to do it with this. So, what typically were we doing before when we went into doing shifts of things? Well, let's see. The shift in my exponent is going to be my left-right shift. Okay? Remember, it's going to be the opposite of whatever my sign is. So negative, you think you're going left, but you're not. Negative means I'm going to shift my graph to the right. When I see the value at the end, okay, that's my up or down shift. But that actually is what you see. So a negative will be a downward shift. A positive would be up. So you're like, okay, so kind of how does this work? Here's how I'm going to have you look at this, because I want you to physically see how the shifts work. My base graph here is going to be what I would do if there were no shifts. So it's 3 times 2 to the x. So here, I'm going to go ahead and I'm going to graph 3 to the 2x. Don't do everything else yet. So I want you to see how this works. Then we'll get the shifts in there. Oops. 3 times hardy time. This would be so much easier than writing in calc. There we go. 3 times 2 to the x. Okay. For my initial point, okay, I'm not going to fill in the chart. I just want to get a little bit of an idea of what's going on here. So I'm just going to plot a few points. Like that 1, 6, I'll go ahead and plot. 0, 3, I'll go ahead and plot. And I'll go ahead and plot -1, 1.5, 2.75. Now I'm not going to connect them quite yet. So I want to see what happens when I go back in a minute and graph this with these actual shifts. Because I want you to see what happens to those 4 points. So when I come back, I'm I'm just going to tweak this one a little bit. My exponent here is x minus 1. And I have to close the parenthesis to let it know that's all there is for my exponent. And then I'll do the minus 4. So this is what the actual graph in number 9 is going to end up looking like. So I graph it, and I'm like, woo, went down and over and all sorts of places. But here's what I want you to end up seeing. So you're like, okay, so Hardy, what's the big deal here? If we were just doing those regular shifts, what would I do? I'd be going right 1 and down 4. I'm off on the screen. So let's look at this for a minute. If I was at 1, and I went right 1 and down 4, where do I end up? 2, 2. Huh. There's 2, 2 in my chart. I started here at 0, 3, and I went right 1 and down 1, 2, 3, 4. I'm at 1, negative 1. So what you're actually doing, if I started here at that 1.5 and went right 1, 2, 3, 4, 0, negative 2.5. You can do all the shifts. You could just graph the initial one and graph shifts to be able to see where they're at. Okay? Can I go ahead and use the chart if I want to? Sure. I mean, that's not wrong if I do. But I'm just saying you have an option if for some reason, sometime you were having an issue with not having one of the fancy calculators, that you could actually do it just with this shift. But here's the cool thing. This new graph that I have, there's one difference I want you to pay close attention to. My domain's not going to change. It's still negative infinity to infinity. But what happened to my range? Where's my new bottom point of my graph? Negative 4, where the up or down shift was. Oops, almost forgot my negative. That's what I have to keep in mind. I should be able to tell domain and range without ever graphing. Just knowing what that shift is. Now, if it was up, my range would go up to a positive. Okay? And my shifts, I could have written them here. I right 1 and down 4. And I get the information that I need. So in speaking of it that way, we shrink down the calculator, so we don't need it for the last part. And the notes will be nowhere near this long tomorrow. This is just kind of a long process. Initial graph, new graph. What shift is there going from original to new? Down 3. It's not in the exponent. My domain still is not changing. Okay? It's not changing. Never, 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 never. But what did that shift do to my range? Negative 3 to infinity. Now, let's see here. Okay, this one's going to be right 1, because it's the opposite of what I think when it's in the exponent, when it's a left or right shift. Does that change my domain? No. Does it change my range? No. Okay? The only time my range is going to change is when there is an up or a downward shift. Left and right shifts don't change my range at all. So with that in mind, what shifts do I have in 12? Left 1, keep that one, down 2. It doesn't change my domain, but what's it do to my range? Right, it boosts it down to negative 2 and off to infinity. So, what your task is going to be